Hello, everyone, and welcome to the Varsity Tutors StarCourse series, where today we're joined by Fatima with the Pacific Science Center in Seattle, Washington, and we are on a mission to learn about missions to space, and specifically how scientists and engineers will use robot technology to learn about faraway planets like Mars. Now, before we get started, I want to make sure we are all prepared to collaborate and learn together as much as possible, so just a few quick things to keep in mind. First off, we're going to have some opportunities to participate. Fatima will have some questions for you, and you'll likely have some questions for her as well. So feel free to use the chat panel on the right-hand side of your screen to both ask and answer questions throughout the lesson. If we don't get to those questions right away, not to worry, we're going to save a few minutes toward the end of the lesson specifically for Q&A. You'll also want to be sure that you have your cameras close by, because toward the end of the lesson, we're going to have an opportunity to lean into the screen and pose for a selfie. And if you post those selfies on Instagram and you tag us here at Varsity Tutors, as well as the Pacific Science Center, you'll be entered to win a 1-week subscription to the Varsity Tutors virtual summer camp of your choice. I'll talk a little bit more about the specifics of that prize and how you can enter toward the end of today's lesson. But for now, I'm going to go ahead and pass it along to your instructor for today, Fatima. Take it away.
Thanks, Haley. Hello, everyone. It's so great to be joining Varsity Tutors again here with Pacific Science Center for our program, Robots on Mars. Now, as we're getting started with this program, I actually like to kick things off with a question for all of our learners. And my question is, would you ever want to travel to the planet Mars if you could? So you can let me know in chat what you're thinking. Maybe type in a Y for yes if you're like, absolutely, I'd go there today if I could. Maybe a big N if you're thinking, no way, I like it here on Earth. Maybe a question mark if you're not super sure. Maybe you're kind of still thinking about it. What do we think? Okay. Seeing a little bit of a mix here. So I do have quite a few Y's, some yeses coming in. So maybe some of our learners super excited about thinking about maybe getting to travel to another planet. I do see some big no's, some potential question marks, some scientists maybe still thinking about it. No worries here. I think I'm kind of in the middle myself. So I would also maybe be more of a question mark. Now, scientists, I am kind of curious. What were some of your reasons for coming up with those different decisions? So if you were thinking, yes, absolutely, I'd go, what are some reasons you would want to go? Or maybe if you were thinking, no, no way, let me know why not? Why would you not want to try traveling to a place like Mars? You can get those ideas here in chat. I'll give us a moment to share. Okay, right away, I see if some of us just saying it sounds like it would be pretty cool. Yeah, absolutely getting to try something new, getting to explore a new place. Some of us thinking about potential science or discoveries we could make, learning new things, absolutely. Some of us also talking about some of the challenges though, absolutely. There's no air in space that we are able to breathe. Mars is super far away. It would be kind of a dangerous journey. Oh, some of us kind of worried about not being able to get back. Okay, these are all some really great ideas, scientists. And you know what? We actually have scientists working for groups like NASA here in the United States and other groups around the world who are trying to actually think about human missions to Mars. And they have some of the same ideas we were just sharing now. So wanting to go because of the potential things we could learn and discover, but also not being able to do so just yet because of some big challenges. So for now, our scientists at places like NASA are working on trying to learn things about Mars that can help us with getting ready for actually sending humans there. And we actually have some different questions our scientists are trying to answer before we send humans there. So some of these questions are going to help us with preparing for that human exploration. These are called our NASA science goals. Now, if we're trying to answer these questions about Mars without being able to physically go there ourselves, what are some tools or some ways we could actually try to learn about Mars without going there? So what are some other ways we could try to learn about the planet? If you have some ideas, you can let us know in chat. So how can we study a place we can't even visit yet? Oh, I see some of us talking about those robots. Yeah, Haley earlier mentioned we were going to be talking about some robots during our show. Robots can be super helpful with collecting information to answer questions. Absolutely. I'm also seeing some ideas like telescopes in the chat, as well as our rovers. Yeah, maybe give yourself a raised hand or a thumbs up if you heard about one of the rovers who made it to Mars last year, Perseverance. Absolutely. Some of us are talking about satellites as well. So these are all some really great different ideas. And actually, these robots, satellites, rovers, they're all great examples of something called remote sensing tools. So with remote sensing, we're actually collecting information without actually going to the places we're collecting information from. So this means our tools like those satellites and our robots are helping us to collect things like sound or images, just like we might do if we were actually visiting a place using our own senses, right? So thinking of like our sense of hearing or our sense of sight, but instead of us using our own senses, it's actually our robots who are collecting this information and sending it back to us. And so right now, our scientists are using our remote sensing tools like those robots we were talking about to help us with collecting information to answer some big questions. Now, one big question we are focused on here for today is actually going to be talking about whether or not we can find water on Mars. Now, we haven't brought up this question just yet. Earlier, we were talking a little bit about some of those NASA science goals. Now, let's take a look at what those goals were again. We were trying to do things like learn about potential life on Mars, if it's ever existed, maybe trying to understand more about the climate or the geology, or even prepare for human exploration. So if these are our science goals, why might we have our robots trying to help us find information about water on Mars? How might water help us with answering some of these other bigger questions we have? You can let me know your ideas in chat, why we might be looking for water, if we're really wanting to know more about these things here. Ooh, yeah, our human explorers are going to need water. Yep, humans definitely are going to need that. Life might be needing the water. Yeah, if we can find water on Mars, maybe that means that there is life on Mars using that water. Yeah, for all we know here on Earth, all of our life here does require water to live, right? So finding water in places in space is a great start to kind of try to look for that search of life elsewhere. And yeah, some other ideas maybe we aren't thinking of. Water can have a big change on our climate. It's going to have a big impact on our geology, so what our landscape looks like. So trying to look for signs of water is a much easier task for our robots to be helping us collect that information to help achieve these different NASA science goals we're working on. Now, I do have an example of one picture that was actually taken by a robot on Mars. So this picture here was taken in Jezero crater, a place in Mars, or on Mars, I should say. And this was actually taken by that latest rover we were mentioning earlier, that robot Perseverance, who made it here on Mars last year in the late winter. Now, taking a look at this picture, scientists, are we noticing any signs of water that we can easily see in this picture the robot took? You can give me another one of those Y's for yes, maybe an N for no, maybe a question mark if you're not so sure. Okay, a bunch of N's, a bunch of no's coming in chat. Yeah, not really any clear signs of water, just looking at these pictures, right? So sometimes when we're looking for information from our robots, it's going to be a little bit tricky just finding exactly what we're looking for. With water, that's definitely true. We might not find like a giant body of lake, but our engineers and scientists can work together to come up with the right tools and missions to help our robots with looking for signs of things we're looking for, in this case, water, maybe using some more unique or not thought of ways of evidence. So we're probably not going to find a big river running on Mars today. That'd be super exciting if we did, but that doesn't mean we can't find signs of it elsewhere. And so our remote sensing tools are super helpful with this challenge. We're going to be learning about a few missions where remote sensing is helping us search for water and hopefully helping us with achieving those NASA science goals. And while we're working on learning about these missions, scientists, I do also have a challenge for us. So here in the studio with me today, I actually have with me this mystery bag of science. Now, inside the bag, I've hidden away one mystery object. So the object is already inside the bag. And scientists, it's going to be your challenge from wherever you're learning today to try to figure out what that mystery object is using some of those skills we're seeing our scientists use with using remote sensing. So for this challenge, I will be working as your robot, helping you collect information. And I'm going to be doing that without opening up the bag to make it even harder. And I will say right away, the item has nothing to do with Mars. It's actually going to be something that comes from a school. And so the object is going to be coming from a school, which means it has nothing to do with Mars. And so this is a really great example of how remote sensing can help us with solving all types of questions, not just the ones about outer space. So let's go ahead and take a look at getting started here. First, we're going to try actually by learning a little bit about how our scientists at NASA conduct their missions with their remote sensing tools. So let's take a look at how they do that. So to start, we learned that our robots are helping us collect information about this big question: can we find water on Mars? Now, this big question is still kind of hard for our robots to answer all by themselves, right? They're just collecting information. Thinking on their own can be kind of challenging. So it's important for our scientists to kind of break down this big question into some easier sections that their missions can work towards. And so the 3 sections we're going to be learning about today look like this. So maybe you've seen one of these before. You can let me know with a yes in chat if maybe you've used a chart like this, maybe in school or we're learning on your own. So we have 3 categories here. One category saying I know, the second saying I want to know, and the third saying I learned. So some people might refer to this as a KWL chart. I see some of us in the chat saying they've used something like this before. Yeah, I know these are super popular in classrooms too. So for our scientists using their KWL chart, this means the first thing they're going to think about with their mission is what they already know. And there's actually a few things we already know about water and Mars. For example, we know that finding water on Mars can help us answer some of our bigger questions, those science goals we were talking about. We also saw in some of our pictures that finding big bodies of water isn't really easy to do, but we also know that we can use our remote sensing tools to look for evidence in other places. And so what do our scientists want to know? Well, they want to know a little bit more about a couple different things. First, can we find any signs of past evidence of water on Mars? And 2, is there any evidence of present day water? So our missions are going to be working on these smaller questions to help us with adding to what we've learned, to hopefully help us answer our big question. Now let's go ahead and meet our first robot here, helping with these smaller questions. So our first robot is named Curiosity. So Curiosity is actually a rover currently on Mars. It's been here for over a decade, actually, collecting information in a place called Gale Crater. Now, Curiosity is actually a pretty big rover. Just to show us the scale here, Curiosity is about the size of an SUV, so it's bigger than a human. So these are actually really big robots oftentimes. And I also have here a 3D model of Curiosity. So scientists, let's take a look at some of the parts our engineers have designed to help Curiosity with its mission of collecting information about what's in Gale Crater. So scientists, go ahead and take a look. Try making some observations of parts that you're noticing on the robot. You can share with me in the chat any observations you're making. So what are some tools you can see? Well, a couple of us are noticing those wheels. Yeah, Curiosity has 6 super strong, super sturdy wheels that allows Curiosity to rove or move about here in Gale craters. That's why we call Curiosity a rover. I see some of us also noticing a camera. Yeah, I kind of think that that camera almost looks like a face here on Curiosity. So we do have a camera up here. There's actually a few different cameras on Curiosity though. So actually this picture was a selfie that Curiosity took on Mars. And so that was another camera attached to this super long arm on the robot. I see some of us also asking, is that a drill or something on the arm? Yeah, so Curiosity does have a drill here that it uses to dig into the surface here on Gale crater, where it's located here on Mars. Okay, so these are some great observations, some of the tools here on the rover. So let's go ahead and take a look at what Curiosity has been using those tools to do. So let's see. So Curiosity's main mission that we're talking about today is actually studying the surface of Gale crater, taking a close look at the rocks that it can find. So actually it's using that super long robotic arm. It's actually 7 feet long just about. So scientists, if you want to imagine kind of reaching out with your own arm and using the camera at the end of your arm to scan the surface of whatever is in front of you, that's exactly what Curiosity is doing here on Mars in this crater. And while doing this, one of the pictures that Curiosity found was actually this picture we're looking at here, showing all these little small pebbles, which scientists have been calling Curiosity's pebbles. So let's go ahead and take a look at why these rocks were super exciting for our scientists to find. Now, to start, let's actually try comparing these rocks to some rocks from here on Earth. So I've got the Curiosity rock sample, those Martian pebbles that we discovered here on the left of our screen. And over on the right, I have some different Earth samples. So scientists, let me know in chat, which of these samples looks most like the ones from Curiosity. So trying to match up the best one. So you can let me know in chat just by typing in that number. So 1 for that first sample, 2 for that second one, 3 for that third sample. And I'll go ahead and pause here to give us some time to share ideas. Although I am seeing a lot of 1s right away. So maybe this was a pretty easy challenge, maybe a couple of 3s, mostly 1s, not really seeing many 2s at all. Okay, so if we're thinking that first sample looks like the best match, I kind of agree, but I would love to hear why. So what were some of the things you were noticing that made that first rock sample look really similar to the sample that we have from Curiosity? What about them looks so similar? Okay, some of us saying the color. Yeah, so when we're talking about rocks, the color that we're seeing can tell us a lot about how the rocks formed. It can also tell us a lot about what the rocks are made of. So it's a great observation. Ooh, some of us are also noticing the size and the shape though also. So I'm seeing some of us talking about them being kind of small or medium size. But they're all kind of smooth and they've got like that really round shape. They're not sharp or pointy like some of the other samples. Yeah, these are some great comparisons here. I agree. So these rocks from both the sample from Earth on sample 1 and the Martian pebbles from Curiosity do kind of have that rounded shape, and they're kind of small, really. It kind of seems like they were broken up a little bit. And so scientists, we actually just use something called the physical properties of these rocks to help us with making that comparison. So physical properties can be things that we observe when we actually looked at an object. They don't require any special tests for us to learn about. And so physical properties are super helpful for identifying objects when we're working with remote sensing, since it's really hard to run tests on things when we aren't physically able to actually hold or touch the object sometimes. So physical properties can be super helpful for our robotic missions here on Mars, where we're trying to understand what our robots are actually finding. And so some of us in chat were using those examples like the color of the rocks, the shape, the texture, the size. And these are comparisons we can make just by looking at the pictures. We didn't actually need to hold the rocks to be able to make these comparisons. And you know what? There's something really exciting about the comparisons we were making. That first rock sample that we all thought looked like the best match was actually a sample of Earth river rocks. So thinking about how Earth river rocks get their shape and their texture, does anyone actually know? You can let me know in chat if you have any ideas. So why are these Earth river rocks so smooth and rounded? Ooh, erosion, bumping into each other in the water. Yeah, so thinking about where our river rocks are located, right? So they are in the water, they're moving around, they're bumping into each other, they're tumbling all over the place. And you're right, for some of us saying erosion there in chat, erosion is that process where wind and water can actually break down rock and smooth them out. So our Earth river rocks look like this because they've been in water. And with the Martian pebbles from Curiosity, that rounded, smooth texture and shape also gives us some pretty good evidence that maybe these pebbles were once long ago actually in some moving water. And that's why they look like how they do today. Now, we don't know this for sure, right? We weren't able to see these rocks here from Mars being formed. So our scientists do want to be careful with not jumping to assumptions, right? So when we think about what we've learned, it's really important to just think about what those observations are and use those observations to help us as we collect more information to come up with some new ideas. So for now, our Curiosity discovery is showing us those pebbles with that smooth texture. And we do know that smooth texture could be possible evidence of erosion. All right, so scientists, well done taking a look there at Curiosity's mission and learning a little bit about how remote sensing is using those physical properties of objects to help us with making some identifications. I think we might be at a good spot to pause from our missions on Mars to take a look back at that mystery bag challenge. So remember, this was the mystery bag where we have an object hidden away that has nothing to do with Mars, but we were going to see if we could try to use remote sensing to figure out what the item is. So scientists, let's go ahead and try actually following some of the steps we saw our scientists over at NASA taking. So I remember one of the first things our scientists did was they figured out a big question and broke it up into some smaller pieces. So let's actually try doing that ourselves. So I'm going to bring up our own blank KWL chart here. So this will be used for our mystery bag of science. Now, the first thing we need to do is figure out what is our big question. So I'll put that up here at the top. So scientists, let me know in chat, what was the big challenge, the thing we were trying to answer about our mystery bag? Yep, I see a couple of us mentioning it in here. It's kind of silly, right, compared to the Mars one, but we were trying to figure out what is inside the bag. Absolutely. So hopefully a slightly simpler question than finding water on Mars, but still hopefully a fun challenge too. Okay, so if our big question is what's inside the bag, I think our next step here is to break it down into those three smaller categories. So starting off with what we know. Now, there were a few things we learned earlier in the show, right? We learned, one, that we can use remote sensing to help us collect information about the mystery item. We also learned that the mystery item is inside the bag. So that means it fits inside the bag. And so that gives us a bit of a clue if we can learn about the bag size, how big the object might be. Now, does anyone remember where the mystery object came from? They told us earlier in the show, but I didn't reveal what exactly it was, just where it came from. What do we think? Okay, yeah, it came from a school. That's right. So we had those different options here. So it's an object coming from a school. So that's actually something we can add to what we know. All right, scientists, for the next step here, we're going to be thinking about what we want to know. And this is actually something that we can try to use some of that experience with curiosity to help us out with. So remember, with curiosity, we were using things like physical properties to help us with making comparisons that could maybe help us identify the rocks we were looking at. So I'm kind of curious if maybe some of these physical properties might be helpful for us to learn about our mystery object to identify what it is. Now, some of these physical properties are easier to learn about without opening the bag than others. For example, one that I could think of, like the texture, just like Curiosity's rocks, that could be a really good one to try to learn about. So I'm going to go ahead and add that here to our grid or our KWL chart. What about others at home? What do we think? What are some other properties that might be super helpful for identifying our mystery object? You can let me know in chat which ones you would like me to help you collect information on. I'll get those added to our KWL chart here. What do we think? Oh, some of us want to know the weight. Yeah, I think that would be a pretty easy one to try to figure out without opening up the bag. Maybe if I have a scale next to me, I could try to do that. What else? Ooh, the size. Yeah, so if we actually figure out what the size is, right? We talked about it being able to fit inside the bag. So how big actually is the object? How about one more? Oh, see a couple of us saying the color, a couple of us saying the shape. I think the color might be kind of hard for me to figure out without opening up the bag, right? I can't really see through the bag with my eyes, but we might be able to figure out the shape. I think that one could be done without actually opening it up. So let's go ahead and pull that one and take a look at our KWL chart here. So what we want to know are things like the texture, the weight, the shape, and the size here. Okay, let's go ahead and try out one thing to see if we can answer some of these questions here before we go on to our next mission. So scientists, I'm going to go ahead and do something we saw earlier with our rover Curiosity. I'm going to actually show us a scale. So scales are super helpful. This is when we're talking about scale, the way I'm talking about it, I mean something that's going to help us see the size of an object. So not taking the weight, but taking a look at how big it is compared to something else. So right now I have a coffee mug here for scale, and scientists, go ahead and at home, show us with like your hands kind of how big a coffee mug is. If you're learning with someone else, you can try comparing that with who might be next to you. And then let me know in chat kind of how big that kind of would look. Now, it's not a joke coffee mug. I promise I don't have a secretly super gigantic one. This is a pretty normal sized coffee mug, one you might find in your own kitchen at home. So let me know in chat. Is a coffee mug going to be super big, kind of small, maybe medium sized? Okay. Not super big. I'm seeing some small, some medium. Yeah, so if a coffee mug is not going to be super big, that tells us a little bit about the size of the bag, right? So looking at our scale, my bag is about maybe 1.5 coffee mugs tall and about maybe 2 coffee mugs wide. So the bag isn't super big. So we can actually add this information to what we've learned. So let me go ahead and take that back to our KWL chart. So we've learned a little bit about the bag size. And let's see, I think we have enough time to try out one more thing. Let's see if we could try to figure out this texture before we go back to another mission. So to do this, scientists, I'm actually just going to go ahead and take away our scale. And let's see if I just lay the bag down. I don't know, is it looking like the object might be super bumpy or super flat? Are we noticing any parts sticking up? What do we think? Let me know in chat what you're observing. Okay. It's kind of flat. Some of us are pointing out maybe the bumpiness down at the bottom. It's looking like there's nothing really too pointy though. So I'm going to go ahead and say in that KWL chart that it's pretty flat. We're not noticing any big bumps. Okay, scientists, I think we're at a good point to try to delete some of these options. So can you let me know which of these objects we can get rid of, and let me know why. So which of these aren't matching what we've learned so far? Yeah, definitely can get rid of the school bus. I see a few of us mentioning that one. Probably way too big for a bag the size that we have it. Some of us also saying the desk is probably too big. Also, maybe the clock and the lunchbox. Yeah, the lunchbox wouldn't really lie super flat, I don't think. Okay, I see a few more ideas. We'll go ahead and leave it at this for right now. So keep thinking about what we might be able to eliminate. But I think we are ready to go ahead and meet another one of our robots helping us out with this remote sensing work and maybe some more tactics on how we can solve our mystery item. So for our next robot, we're going to be meeting a different type of remote sensing tool. So this is actually an example of a satellite. And this satellite is named Mars Express. And Mars Express is actually a special type of satellite called an orbiter. So that means Mars Express just orbits around Mars over and over instead of trying to go to different places in space. And Mars Express is actually a pretty cool robot. It was put together through a team project with NASA and ESA, the European Space Agency, and the Italian Space Agency. And so there's a few different teams that are controlling Mars Express and helping it with its mission. Now, just like we did before, let's take a look and see what are some of the tools we're noticing here on Mars Express that might be helping it with its mission. What do we think? So you can let me know in chat if there are any designs that you're noticing our engineers included that might be helping with collecting information for our scientists. Oh yeah, solar panels. A few of us are noticing those. Some of us are saying it kind of looks like wings. Yeah, the solar panels here, those blue squares on all the sides here, those are going to help power Mars Express, which keeps its mission going nice and long, helping it to get that power it needs to do whatever it's working on. Some of us are also noticing it looks kind of like gold foil. It kind of looks like a pizza box maybe, or delivery box. Yeah, that's actually a really good connection there. That gold foil does indeed help protect the robot from radiation. It also helps keep the robot nice and warm. So I think calling it a delivery box kind of works perfectly actually. Some of us, so instruments, yeah, definitely have some instruments, some different tools that are kind of on top of that box. And I saw some of us saying it kind of looked like a satellite dish here. Yeah, that is indeed going to be a dish here that helps with that communication from Mars Express. So Mars Express is able to collect information here inside this dish and then remotely send that back to Earth using another tool that's kind of hard to see on this model here. So actually taking a look here, you might notice these really long rods that almost look kind of like a glitch in this model. So these are actually going to be super long antennae that are over 100 feet long that are helping Mars Express communicate. So we're going to be taking a look at Mars Express's different mission goals here in just a moment, how those tools are helping out. But Haley, I'm wondering if this might be a good chance for a selfie since we've got such a good view here of such a very big robot helping us out in space.
I think it sure would. So as a quick reminder to everyone, while you're getting those cameras at the ready, we encourage you to take that selfie and post it up to Instagram and tag us here at Varsity Tutors, as well as the Pacific Science Center. And I'll put those handles up on screen at the very, very end of today's lesson. And as a quick reminder, if you do so, you'll be entered to win a 1-week enrollment to the virtual summer camp of your choice. So maybe you want to learn a little bit more about STEM, or maybe a little more about communicating with these robots with some coding camp. But regardless, there is a camp for you. And with that, we'll take a closer look up on screen here and lean into the screen for that selfie.
All right, I'll give us another angle here with Mars Express. Maybe getting those solar panels in there. All right, well, hopefully you were able to get a pretty good shot of you here with Mars Express. I think we're ready to go ahead and take a look here now at what our satellite has been using those tools, those instruments we were pointing out to actually do. So let's go ahead and see what Mars Express's mission has been. So Mars Express is actually from outer space, so orbiting around Mars, able to scan Mars and take a look at trying to see what is buried below the surface. This works almost kind of like an X-ray. Has anyone here ever had an X-ray done before? You can let me know in chat. Maybe, for example, at like the doctor's office during a checkup, maybe going to the dentist. I know I've had some X-rays taken of my teeth before to help with making sure my teeth are nice and healthy. So this is going to be pretty similar, just using slightly different types of technology. So instead of taking X-ray waves, we're taking these radar scans of the Martian surface here with Mars Express. And so what our radar scans look like are these pictures that I can see right here down in that bottom left corner. So we see like this really dark gray and black picture. It's kind of grainy. We've got some lines on it. Does anyone have any ideas what we might be looking at? No, I don't see too many. I see a couple no's, not really any guesses. It can be kind of tricky to understand what you're looking at radar, right? We're pretty used to looking at like photos that are showing, you know, visible light and things that we can see around us super easily. So radar images can be a little bit more confusing. Now, to start, what we're looking at is actually kind of what we call a cross section. So what we can think of is the top of the picture. So the really black part is going to be the very, very top of the image. It's also going to be like the surface of Mars. And each layer we go down in that picture is going to be a layer further and further underground. Now, it can still be kind of tricky to understand what we're looking at. So I like to do just what we did with Curiosity and compare Mars Express's discovery to something here on Earth that we might be a little bit more familiar with. So we're actually using radar scans here as well to help us look underground. And actually we have a mission going on at Antarctica using radar scans to see below the surface of the icy continent down south. Now, one radar scan we have here from Antarctica, we can see in this picture. So you might notice we've got some different layers here in the picture. We also are looking at that cross section. So the top of the picture is showing us closer to the surface, and each layer we go down below another surface part. Now, the section here in this radar scan that our scientists were super excited about is actually in this box here. So I have it highlighted. Now, scientists, I would like to hear, what are you noticing inside that red box? How does it kind of compare to the other parts of the picture around it? So is there anything that you're seeing in that red box that you'd like to describe, or anything else you're noticing? What's looking kind of bright. Yeah, some of us are noticing maybe like that section, the very middle of the red box is looking really white almost, really bright color compared to some of the other things. Some of us are noticing that dark crack. So maybe it's like a crack in the ice, one person is wondering, going up top of it. Yeah, so we've also got that crack kind of outside of the red box over here. And I see some of us are also noticing that it's got these waves. So it kind of looks like maybe sand or that kind of like graininess going around in a wave. Okay, interesting. I also see one of us mentioning that shape. So it's kind of long and bright inside that red box. All right, these are some great observations. Now, let's go ahead and take a look at what we actually discovered here to help us understand what this radar scan is really showing us. Are you ready? I'll go ahead and reveal it here in 3, 2, 1. So scientists, this radar scan is actually showing us an underground lake that was discovered below all the ice here in Antarctica. So those wavy parts, what some of us were noticing, we're actually showing us the different layers of ice on top of the lake. And when we get down to that part where the red box is, that super bright line some of us were noticing is actually the surface of the lake. So what's going on here? Well, with radar, our radar waves, when they hit the surface and go below, a couple of things can happen. Either those waves can get bounce back out into outer space or to whatever the object is we're using to send them. And that happens when whatever they hit is super reflective. So things like water and ice are super, super reflective. Water is actually a little bit more reflective than ice. And so objects that are really reflective in a radar scan are going to show up really, really bright. And since water is a little bit more reflective than ice, that's why the part here showing water is showing up a little bit brighter in our picture, even if it's just a tiny bit, since there's so much reflective stuff in here. Now, the opposite could happen though too. Instead of getting reflected, these invisible waves can actually sometimes hit something that absorb them. And this is going to show up really dark in our radar scans. So some of us were noticing that dark crack or those wiggly squiggly lines that look like a crack here in the middle of that radar picture. Those darker lines are coming from rock or dirt. So rocks tend to not be super reflective unless they're made of something a little bit special like a metal. But a lot of the rocks we might find typically are going to be absorbing those radar scans. They show up a lot darker in the images we find. Now, scientists, let's go ahead and bring back that image from Mars Express and take a look at making a comparison. So here I've highlighted a couple parts on the Mars Express image to show us where our scientists were super excited. So what are we noticing here comparing that Antarctica scan to that scan from Mars? Any similarities? Any differences? Ooh, we've got some of those white strips where it's looking brighter. We've got some bright spots and some dark spots. Yeah, so we've got some dark spots that might be absorbing those radar waves. So thinking of those rocks or dirt. And then absolutely, we have some bright spots that are something super reflective. Now for Mars, we haven't dug down below the surface here to find out what's really buried here. So we're not sure if it's actually water, but it could potentially be possible underground lakes. Or maybe we've discovered something new that's showing up super, super reflective here, something we weren't expecting to find. So either way, it's a pretty exciting discovery. Maybe one day we'll be able to dig down and actually see what this reflective stuff is. For now, what our scientists are thinking that they've learned is, well, we have something reflective under the surface, right? So this could lead us to maybe funding a mission in the future to try to drill down and actually figure out what this is, since it's an exciting possible discovery here hidden below the ground. All right, that radar scan did give me an idea of how we might be able to try to figure out some of those questions we were still kind of wondering about our own mystery here. Some of us were wanting to know more about the shape and that exact size. So scientists, here's what I'm going to go ahead and do. I don't unfortunately have a radar scan that I can take here, but I think I might be able to show us what is below this layer of the bag without actually opening it up. So here's what I'm going to go ahead and do. Let me see if I can just try to push the bag around the object a little bit so we can get a sense of its shape. And scientists, I'll go ahead and put a pencil here next to it so we can take a look and see kind of how big and what that shape is. So let me know in chat, what are you noticing? How is this object looking to you? Okay, I see some of us saying it's looking kind of small. So yeah, it's only about half a pencil long on each side. A lot of us are saying it looks really flat and like a square. So scientists, let's go ahead and add that to what we've learned. So we also know the object is flat and shaped like a square. So before we wrap up here today, let's go ahead and head back to those grid options here. Scientists, let me know maybe a few more objects we can eliminate based on what we've learned. So I see some of us are guessing what the object might be, but before we get to the big reveal, what are some more things we can eliminate based on the properties we've observed so far? So that flat square shape. Okay, some of us are wanting to get rid of the sharp, pointy things like the scissors, absolutely, and the pencils. I see someone wanting to get rid of the crayon and the pencil case as well. Okay, these are all some great eliminations, I think. Was someone also saying the laptop because it was too big? Okay, yeah, let me get rid of that one also. So scientists, go ahead and think about what your guess is then. What is the mystery item? You can let us know in chat or you can share with someone next to you. And I'm going to go ahead and reveal what our mystery object was. So let's see, how well did we do with using our remotely collected information? Are you ready, scientists? Maybe give me a drum roll from wherever you are in 3, 2, 1. Ooh, was anyone thinking it was going to be the sticky notes? Let's see. Oh, I do have a lot of guesses. It actually looks like that's what most of us were thinking. So well done, scientists. Go ahead and give yourselves a round of applause. So you were able to use remote sensing here today to help you with answering that big question of what was inside the mystery bag. Now, what about for our scientists over there studying Mars? Do we feel like we collected enough information that's helping us really understand that idea of whether or not there's water here? What do you think? You can give me one of those Y's for yes and N for no, maybe a question mark. Yeah, I'm seeing a lot of no's. Maybe, yeah, we are going to need to collect more information, right? 2 missions is definitely not going to be enough to be able to help us with achieving the questions and information that we need to be able to figure out to really get those NASA science goals achieved and prepare for human exploration of the planet. And so this is why we're actually sending more robots to Mars. And it's not just NASA. So there are scientists around the world. This right here is Perseverance, the most recent NASA rover. We also have here Zhurong, a rover from China over on the other side of Mars, and even more missions. So there's a lot going on to help us with collecting information remotely here at Mars to hopefully one day prepare for that human exploration. It hasn't happened yet, but using these strategies we've been learning about here today is getting us closer in that direction. And so scientists, I hope you had a fun time learning about remote sensing and our robotic missions, helping to prepare for human missions one day. Haley, I'll go ahead and turn it over to you to get us started with our Q&A here.
Awesome. So you mentioned this in the very, very beginning of the lesson, and you foreshadowed it a little bit toward the end of the lesson as well. But we had some very, very curious scientists who had some really cool suggestions around how we might implement things like water sensors and spacesuits and all sorts of other really neat inventions, who were wondering why it is that we might send remote technology and utilize these robots rather than sending people. So could you remind us, maybe in the case of Mars or even in general, why we might be sending these robots rather than astronauts?
Yeah, absolutely. So one of the big things has to do with safety, right? So our human explorers are going to need some really important resources and some really good technology to keep them safe and able to survive space. We have been adapted to live here on Earth, and so those things don't really exist easily in outer space. We need to figure out a way to actually get them. And so our robots are great tools to help us with collecting that information that helps us learn about Mars, understand what resources might be there or what types of conditions our scientists might encounter if they were to go there. And that helps us with preparing for those human missions to one day go there. So our robotic missions are kind of almost like scouts going ahead to help us collect that information, to make things a little bit safer for our human explorers before we actually try to send them out? It's a great question.
Absolutely. Now, we also had some very curious scientists who were wondering some of the tools that you're using to take a look at some of our robots up close and whether they might be tools that they could use at home. So could you talk to us a little bit about tools that our students might be able to use to learn a little bit more about some of what we were talking about today?
Absolutely. So I was actually using some 3D models that came from NASA here today. Haley, I can put in chat for you to share out with families. One of those 3D models. I really recommend spending a little bit of time on NASA Space Place. I can get that link in chat here also. NASA really wants to share the education side of its missions also. And so they're constantly creating things like 3D models or simulations that scientists can explore. And I'm actually going to put in chat for you, Haley, something called NASA Eyes. So it's another fun simulation where you can take a look at the solar system and learn a little bit about some of these missions. So if you want to try exploring other places, not just Mars, this is a great tool to try to collect some of those cool ideas.
Awesome. And for anyone interested in checking out those links, we'll be sure that they are pasted on the YouTube recording of this class. So definitely feel free to check it out and explore even further than today's class. We also had some really fun questions around. We got to hear some of the titles of some of the craters, some of the rovers, even some satellites. So how is it that these craters, that these satellites, that these rovers come to find their names?
Yeah, it kind of depends. So NASA has some different naming conventions. Those are going to be connected with different agencies related to astronomy. So it's kind of a global effort where we all agree on what these names are going to be. For things like sometimes planets or craters or features, it kind of depends. Sometimes there'll be like a theme. So for example, with a lot of the craters here on Mars, currently we're trying to come up with indigenous names to help share with them. There's places in outer space like out by, I think it's Neptune or Uranus, where their moons are all named after like characters from Shakespeare. With some of our missions, like our robots, some of these are actually named during contests. So Perseverance was actually named by students. So NASA put out a contest request to send in your best name for the rover. And with that, you had to share a little essay on why you thought that name would be a good fit. And we selected, or NASA selected, the name that won that contest for the robot Perseverance. So it really kind of depends on what the actual thing is we're naming. And then there's a few different ways we might come up with it.
Wow. So whether it's future scientists looking to pursue a career in space or even just current scientists looking to participate, we have the ability to make our mark on history by looking into how things are named as well. That is so cool. Now, speaking of, we have lots and lots of very curious future scientists today who are wondering what sorts of things they should be doing now that are going to be relevant to a career in science or a career working with or even in space. So as perhaps today's final question, could you tell us a little bit about some things that our future scientists should be thinking about now that may be related to a career in the sciences?
Yeah, I think it kind of depends on your interests, right? So if you're really interested in the sciences, in particular in space, there's a lot of stuff that's currently happening that's kind of shaping what astronomy and space science looks like. So there's a good chance that maybe there's a future career that doesn't even exist yet that you could help create thinking about your interests. I actually think I have some examples. I don't have all the pictures on here, unfortunately, loaded, but this right here, these are some of the individuals who helped with the Perseverance mission. So this person here, Sydney Fernandez, actually studied a lot of design work and worked in video game creation before working at NASA as a user interface developer. So her and her team actually created some of those 3D models that we were using during today's program. And those are also sometimes used to help with like training for future missions, like landing on the planet or things like that. So if you're someone who likes video games, that's a great example of connecting that art to the sciences. We also have individuals who help more on like the admin end. So I've got here Joey Jefferson, who's the space or the Deep Space Network scheduler. So that means he actually coordinates with teams around the world on using these giant satellites that help us with actually communicating with our robots. And so learning about that teamwork, that coordination, schedule making is another fun way to actually get involved with these missions. If you're someone who's super interested in the engineering side, though, there's definitely some fun places for folks who like that tinkering. This right here is Alan Chen. He was actually the Mars lead for actually landing Perseverance on Mars. So he had to study a lot of physics, a lot of engineering in order to be able to make those calculations. That really tough math that is super, super important, takes some practice to learn. So I think it kind of depends on finding your own interests. That's the really cool thing about space, is it's super easy to connect to those different interests and find a fun career.
Awesome. Well, thank you so much for giving us a little bit of an introduction to that and to the curiosity required to start to pursue a career in the sciences. I know even things as seemingly simple as those KWL charts that we looked at today, we saw are relevant to what scientists in the field will do on a day-to-day basis. So this was so, so cool. Thank you so much once again, Fatima, and to the entire team at the Pacific Science Center. We do hope to see everybody's selfies, so don't forget to post them and tag us both. And in the meantime, we hope to see you back in another Varsity Tutors StarCourse soon. Thanks, everybody.
Thanks, everyone.